Now that we have looked at what the complex conjugate is, let's take a look at some of their properties. Now, these properties 1, 2, 3, 4, 5 that you see in your notes, now they are properties that you can straight away code and use in your work. Now, the proof are all relatively easy. Let's take a look at how and what they are. Now, number 1, Z conjugate is equals to Z. Now that seems rather intuitive, but let's take a look at how we prove it. Now if Z is the same as x plus iy, now what is Z conjugate? It is just x minus iy. Okay, so if I have Z conjugate, now that means what? That means first I replace the Z by x minus iy. Then what does conjugate do to x minus iy? You change the minus back to a plus, so you get back your Z. Done. Now if I look at the second property, Z times Z conjugate, now that's just the sum of the real and imaginary parts, square and square. Now the proof goes like this: if Z and Z conjugate, multiply them together, is the same as x plus iy multiplied by x minus iy. Now if you multiply them using the usual way we multiply, x times x, x times minus iy, and so on, okay, you realize that you will eliminate all the imaginary terms, okay, meaning you get x squared, right, minus I x y, then plus I x y minus I squared y squared. Then this term and this term cancels away, and then you end up with this piece. And then that will give you x squared plus y squared, because remember, I squared is minus 1. Now the third property, Z plus Z star or Z conjugate, is the same as 2 times real part of Z. Now how do you show this? Again, this is very easy. Okay, if you replace Z by x plus iy and Z conjugate by x minus iy, then you realize that your imaginary part will cancel, then you're left with 2x. And 2x, x is just real part of Z, will give you 2rez. Now the same idea goes for the imaginary part of Z, meaning now if I got Z minus Z star, then this will give me 2I imaginary part of Z. Okay, and then how do I prove this? I just do the same thing as what I did earlier. I replace Z by x plus iy. I replace Z conjugate by x minus iy. So you realize that again, the real part and the real part cancels away nicely, and then you end up with minus minus plus 2iy. And 2iy, where y is imaginary part of Z, will give you 2I imaginary part of Z. Done. Now the last one, you can try on your own. Now the last one, Z plus minus w, where w is another complex number, conjugate, is the same as Z conjugate plus minus w conjugate. Okay? Remember, you don't need to prove them every time you use them, you can just code them straight away. Now before we move on to look at more examples, let's take a look at 3 and 4, properties 3 and 4 again. Now instead of writing it this way, Z plus Z conjugate is 2 real Z, Z minus Z conjugate is 2I imaginary part of Z, sometimes we rewrite them like this. We make real part of Z the subject and say that this is Z plus Z conjugate divided by 2. Likewise, from property 4, the imaginary part of Z is the same as Z minus Z conjugate divided by 2I.